Well, hi, good morning, and thanks so much for joining me here in my shop. So today I'm going to be continuing with that radio. We're going to work on the front end tuning. I have some interesting things to show you. Okay, so I have some test equipment hooked up once again to the radio, and we're going to be examining the front end of this radio. Let me get my equipment turned on. The thing is, we're not even going to power up the radio to do this. I have to power up my other equipment here. Won't need this. So, and we're going to need this. And most importantly, we're going to need to look at that display that's in the lower right corner. I'll maximize it when the time comes. So, in fact, you know what? I think I'm wrong. I think we're going to focus first on this guy here. So what I'm doing is I'm going to feed into the front end of the radio, into the antenna. In fact, can't get any more front end than that. The signal coming out of the sweep generator, which is sweeping through the AM band, and then picking up the signal out of the radio. And we don't need this in place right now. I'm picking it up with two devices here. And you can see the clip leads, but this clip is clipped onto the insulation of the wire heading to the grid cap of the first tube. I'm not even contacting, I'm not making metallic contact with anything here. So this is, in a sense, a really bad capacitor connection to this test lead. Likewise, same thing to this one going up to the scope. And you can see some hash up here. The scope is not sweeping in its normal way. The sweep is coming from an output here. So if I stop this from sweeping, this stops sweeping. That means this display is frequency calibrated, with the lower frequency here, the higher frequency here, and the way I have this set up, this is the bottom of the AM radio band and this is the top. Now, the radio itself is tuned to around 700. I'm going to move it to about 1,000,000. That's 1,000,000. And we don't see anything on the screen up here yet, but we will as soon as I start raising the output of this guy, which I'll do now. Okay, and you should be able to see something right here. This is marking the resonant point of the front end coils and tuning capacitor in the radio. This resonant point should be right at 1,000,000 hertz, and that's what I want to find out. Is this really resonating at exactly where it should, or is it a little off? If it's a little off, it make a big performance difference on a radio like this. Also, it could be on, it could be right on the money right here, but it could be off at either end, or any combination of that. So I want to explore that question. The challenge here is using an oscilloscope. It's very tricky to get an exact reading of the frequency. In fact, there's two ways to do it, and neither one is terribly great. So I'd really like to see this on the SDR display that's down in the lower corner. So if we take a look at that display now, I won't full screen it just yet. If you look across it, you can see just in the middle, right around 1,000,000, if you can read it there, you'll see a peak poking up. Now if I tune the radio, let's watch what happens. First, put your eyes on this. I'll tune the radio, and sure enough, you see it move around? It's changing its dimensions too. You can see it moving around. Hopefully moving in conjunction with the setting, the exact setting of the pointer, which also has to be operating in conjunction with the local oscillator, which has to be working in conjunction with the IF frequency, the IF tuning. So all this stuff is all connected together. That's not a good way of putting it. It all relates to each other. So let's take a look at this now very accurately. I'll full screen this. I'll try anyway. See if I can full screen this guy. Okay, so there's a full screen view of the SDR. Now, first of all, you see the red line above there. That's sitting at 460. If you look at the top title bar, I guess you could call it, on the software, you'll see it says 460. So I can use that red line to measure very accurately what this frequency is, just by moving it right on top. And now we see it's 885. So I don't want to fool around with funny numbers like this. I like nice round numbers. So what we're going to do is we're going to put the red line right at 1,000,000 here. Let's get it right at 1,000,000. Okay, now there's a bit of an error, frankly, in this radio too. In the SDR receiver, you can have it set to 1,000,000 and it's actually receiving 0.2 here or something like that. So it's not absolutely precise. I'm just going to keep that in mind. 1,000,000. So I'm now going to tune the radio and I'm going to watch this peak. I'm going to line this peak up with this line. With just watching, just like you are, just watching the screen there. How about we go back to the multi-display? You know what's here now. Okay. So now you can see the scope, and you can also see the SDR, and you can see what I'm doing to the radio. So now I'm going to line that. Where did the red line go? On your, you can't really see it on the. That's interesting. The red line appears to have disappeared on your display. Maybe not. This could just be a video thing happening while I'm recording. I'll look at the big one and I'll do what I said I was going to do. Put this right on 1,000,000. There. I would say that's dead on. Now we're going to take a good close look at the pointer here. I can tell you myself, it is absolutely dead on 1,000,000. So now then that last question is, what about the local oscillator in this radio? The radio's not operating right now. So we're not going to investigate that. Instead I'm going to go to either end of the band and see if this doesn't line up properly. So here we go. Go to, let's say, 600. Okay, so that's right on 600. Now we look at the SDR. Let me take a look here. Okay, so I would make the peak out to be at 598, and that's less than the width of the pointer on this radio. So I can't make it any more accurate. You can't tune this radio more accurately than that. So that's fantastic. So we'll travel up to the other end now. I think this is probably one of the key problems with radios, that it's a little hard to get a grip on and a little hard to know when you got it absolutely right. And I find by using the SDR like this, it gives me a much better impression of what's happening with the radio. Okay, so that's right on 160 or 1600. Now look at the SDR. I'll put this right on the peak again. Okay, I'd say that's the peak there. And it turns out to be 1607. So what I'm going to do is I'm going to tune the radio to move the SDR peak that's showing right to 1600. You know, that's not, and we'll see what it looks like on here afterwards. Okay, so I'm moving the peak on the SDR to line up with that red line. I'd say that's lined up there. And look at the pointer. You know, it's dead on 160 still. It's a little hard to see in the camera, but I mean, it's because of parallax, but maybe ever so slightly high. There's fairly bad parallax with this particular radio, but it's so close. And this explains why this radio works so well too, because the front end is tracking perfectly. So the next step here is to tune up the front end. I'm going to have to read the instructions out because I'm thinking, wow, can you really tune this up? at all, and I don't think the tuning up is so much to increase the power of this front end, or it's much more about getting it into the right place frequency wise, and that's where it seems to be already. So, you know, how can I improve this? I don't know exactly. Okay, so I'm going to study up on the instructions here on the next steps of alignment. We got a pretty good idea where the radio's at right now, and we'll take it from there after. Okay, so the next step actually is to verify that the pointer is on the tuning shaft properly. It has to be, doesn't it? Let's see if I can get all this stuff out of here. It's still with the radio not even switched on. So the instructions say, calibrate the tuning dial by adjusting the scale pointer to the extreme end calibration mark beyond 55 on the dial, while the two gang tuning condenser plates are in full mesh. Okay, so 55, the tuning mark, or the calibration mark. Well, I don't see a discrete mark here. On some of these there'll be like a dash or something you can identify as the subtle hint as to where you should do it. So we'll just pick the bottom of the scale here. So I would call it, well, if anything, it's ever so slightly low, but you know, 1 needle width. So adjusting something like this can be easy or can be tricky. In some cases, you literally can just swing the pointer on the shaft, but not this one. This one is not like that. To change this, I'm not going to change this. I am not going to change this. Usually there's some set screws and stuff up in there. I don't even see them, and there's nothing wrong here anyway. Just verifying that in fact it works the way the instructions say, which it does. Okay, let's take a look at the next instruction here. Up here, something else. Wave trap adjustment. Let me get it right on the screen here. Attach the output of the test oscillator to the receiver antenna through a 200 picofarad capacitor. Ground connections remain connected together. Leave the test oscillator tuned to 460. Adjust the range selector to short wave. Then adjust the wave trap screw to the point which causes maximum suppression. So we already have a notion that this is working fairly well, because I tried pumping 560 from the antenna into the radio. It didn't really make it with any strength, but we will check this. This radio has to be operating for this. Standard broadcast. 600. So here we're doing, this is the next step, doing the oscillator. Great, we'll be ready for that. Well, let's do this. Wave trap adjustment. Wave trap screw. Well, okay, which one's the wave trap screw? Wave trap screw. Maybe it's here. Oh, there we are. Wave trap L1 460 here. Okay, so we get the radio operating, pile in a 460 signal into the antenna, adjust this for the lowest reading on my meter, which is monitoring the it's right here. Okay, back to the instructions. There we are. Okay, we start the radio up. This is connected here right to the antenna. I think we want to okay, so I'm going to want to use this other signal generator. That's what I'm thinking. This will be the output. It's supposed to be through a little capacitor onto the antenna. Okay, we can turn on the radio at this point. We can put back in the meter I'm using to monitor the AVC. Meter's grounded. Set to DC. I can hear the, I think I can hear the sweep. Now, the idea here is to pump in the IF frequency into the antenna and then minimize it. So the IF frequency is 460. Now I'm throwing a powerful signal into it right now. Watch the as I tune it in here. So the peak interestingly enough, I'm not getting it at 460, I'm getting it at 462. Oh well, don't worry about it. Not at this point. So now I got to make that adjustment. Okay, I see it. A screwdriver will do it. Trying not to get in front of the camera while I do this. Okay, now we gotta watch the meter. We want the lowest reading on this right now. There we are. Okay, that's done. Next on the hit parade here, adjust range selector to, oh, this was supposed to be done on, well, let's flip it and see what happens here. Went lower. Can't imagine this is going to make much difference. Supposed to do it on shortwave. Oh, slightly different. Let's see if we can very low now. That's very low. Okay. Range selector to standard broadcast. Reduce output of test oscillator to a minimum. Tune test oscillator 600. Set receiver dial 600. Adjust output of test oscillator until slight indication of output is visible. We can use this meter for that. Adjust the oscillator magnetic core screw L. What is that? 3 or 8. Top of oscillator coil. Okay, so I think the oscillator coil is this one right here. To maximize the peak, set the receiver to 1700. Tune test oscillators. Adjust oscillator antenna trimmers. So adjust the oscillator to top end. Go back and forth a few times. L8. So we need to find L8 here. Oscillator coil. Where's that little diagram that I was looking at here? Here it is. L1, C5. L8 underneath. Is there an underneath diagram? L8. L8. There we are. For sure. Just what I thought. I just missed it. L8. 600 kilocycles. I can't imagine what I'm going to adjust here, but let's give it a go. Okay, here we go. Adjust range selector to standard broadcast position. That's where we are. Reduce output to a minimum. Tune oscillator to 600. Set dial to 600. So we'll set this to 600. We'll retune the signal generator here to 600. Doesn't seem quite right there, but let's carry on. Okay, so we gotta see the meter here. 600, very strong signal. Let's knock it way down. There we are. Now we'll make this exactly 600. That is 600 exactly. Now from there, if I tune the signal generator, does the signal go up and down on that meter? Yeah, it went up just a touch. So I'm changing the signal generator less than 1 hertz to cause that. Well, 1 kilohertz rather, 1 kilohertz. How can I possibly improve on that? Again, we're down to questions around, you know, the width of the pointer here and things like that. I just don't see where I'm going to be adjusting this. The same result's going to happen at the other end, because I essentially did this already, didn't I? Well, let's double check it. 1600. Yeah. 1600 on here. This is an idea of a sensitivity also. So you can just see it on the meter there a little bit. Watch the meter. Oh, I heard it. $1,600 there. 1610 close. And look, see, this is just so. So I'm pretty sure I tuned the radio, didn't even move the pointer. That's what it looks like. Yeah, you know, I cannot improve on this. I really can't improve on that. Okay, that's good. Tried what I could. Let's go on to the next thing. 1700. Oh, these two. Well, one of these, carefully adjust the oscillator antenna trimmer. The antenna trimmer I am after. This one is worth doing. Which one is it? Is it respectively? Oh, good. So oscillator antenna trimmer, oscillator antenna trimmer C4. So I must find C4 at 1700. Okay, let's go up to 1700. Wait a minute, just move this up. Sorry, I'm not getting this on the screen sometimes for you to read too. 1700. Well, we're at 1600. Why can't we do it here? Shouldn't we do this with the full power on the radio too, Jim? Come on. Okay. We gotta find where C4 is. That's one thing I gotta do. Where is C4? Go back to that diagram here. Here's C4. Antenna 1800, so it's the one closest to the capacitor of these two. Antenna C3, so this is for the short wave. Excellent. Okay, so we're going to tune this guy. You know, if you're going to change the kind of antenna you've got connected to the radio, you might have to retune these guys. Number A, 1700. We'll do it at 16. We'll be radical. Do it at 16. Okay, I'm going to move the camera so it's not getting in front of it. Stepping on stuff here in my shop in case you're wondering what all those sounds are. And oh my gosh. Okay, so there's the tuning guy. Hard to access here. I need my bent tool to do it. Okay, I'm ready now. Watch that meter. Down. Up. You know what? This is barely making a difference. This is not making any difference. There's something going wrong with this. A little test here. What am I doing wrong? So this is definitely C4. Let's double check that first. C4 is this one closest to the big capacitor, right next to antenna coil. Definitely in the correct thing. Now, what does it say again about it? Is there something I missed here? We're doing C. And what's it say exactly? Set receiver pointer to 1700. Okay, I did it at 1600. Is that why it's going wrong? Tune the test oscillator. Okay, let's go do it at 1700. Okay, so the scale is kind of crammed at this end, meaning 1700's kind of hard to put the pointer on. 1700. $17.16 is what the radio is actually receiving. Pretty sure I got the pointer on the mark here. If anything, it's low. It's no, it's high. If anything, it's a little high. You can see how ridiculous doing this with this kind of refinement. Okay, let's watch that meter again. Peak is there. 1730. Let's do it the other way. I'll set the frequency generator to 1700, and now we'll find it on the dial. $1,700, not quite dead on. For some reason 16 was fine. If 17 is off, 16 should be too. Seems a little off. Let's do the same thing. We'll set this to 1600. Okay, and then we'll find it on here. There's a noise signal in there, and that noise is getting detected. Look at how close I am. Holy smokes. You know, I'm not going to get anywhere with adjusting this. Oh, take it back. Antenna trimmer. Let's go back. We're not doing it. Jim, what's happening in your head? We're just trying to increase the strength here. We're not trying to tune it in. Whoops. I gotta move that thing. This is what you hear me stepping on all the time. Put it over there. I won't step on it anymore. 1700. Now we just want to make this, tune it in so it's maximum on the meter. So we know we have it tuned in, but just a wee bit more signal here. Okay, now try to increase that with the antenna. You know, it isn't even hooked up to an antenna, it's hooked up to my signal generator. So I'm kind of tuning it into a signal generator here. Okay, now watching the meter really carefully. Well, I don't see any changes coming here. Okay, so I kind of smartened up here a little bit. Let me loosen off these locking nuts. It's barely tight. Tight it all. Okay, this is going to make things a little easier. Hopefully. So where are we at? Now we're on short wave, 20 kilohertz. This is the guy I want to be adjusting. Just for the antenna, not for the oscillator. losing control of everything here. So first thing we want to make sure is that this is tuned to maximum over here. So watching the meter. Uh-oh, it's jumping around. There. I'm going to grab that. Grab that control. Oh, moves as easy as can be. So you can see the meter went right down. So again, this is close to being in the right spot. Let's get it down there. What happened to it? It's gone. No, don't do this. There it is, way up here. Now, is this a two-peak thing? Has this one got two peaks? I think for a while the antenna was disconnected because now I get a signal everywhere. There is the spot. It's different. Okay, to do this, put back over to AM. Do it at 1700. Okay. There we go, ready now. I think this is in the right place as it is. Okay. Now we're watching the meter. Don't knock the radio over. There we go. Bingo. Okay, finally. Got that done right. Whew. Okay, that was much more of a struggle than it needed to be. What's next on our deal here? So I'm just gonna short wave, C3, tighten the lock, centering in the loudspeaker voice coil. What? Is made in what? Is made in the usual here. Centering of the loudspeaker voice coil is made in the usual manner with 3 narrow paper feelers after first removing the front paper dust cone. No, this is not something I'm going to be doing. Acetone, yeah, no, that's not happening. Nothing wrong with the loudspeaker as far as I know. I think we're done. There's a bit of a sloppy, pretty sloppy run through there. Okay, I think what we really need to do now is play this radio. Let's play this radio. So we want to put on the external antenna. Off the signal generator. So we are now connected to run down and switch on the external antenna. Is this right? What do we got here? Let me run down and throw a switch. Okay, let's see what we can get. That's really impressive that we can pick up an AM station up here. That's really impressive. So this is among the best radios I've had in here. I'm sorry to say it's not me who kind of brought it back from death. It wasn't near death at all. Buffalo. Might be Buffalo. That's strong.
To participate in the special event at 3 o'clock, right? Everybody's invited, but those will be special. We're going to reveal something to you.
Doesn't get much better, frankly, an old radio like this. So let's go on shortwave. Time of day, where are we here? 10 o'clock in the morning. We'll see what we get. I'm interested to find out. So we're starting at 6 megahertz or 6.5 megahertz. This is very unlikely to hear anything. Hear stuff up around here. Maybe right here. Okay, so those are ham radio operators. So that's a single sideband transmission. This radio cannot resolve a single sideband.
Most people never looked at it that way, John.
This is anti-immigration. People who are against people. I'm against people. Anti-immigration. My God. There he is. Very hard to tune this radio. That's WWV on 10 megahertz, and we're right on 10 here. What do you say? 1013? Okay, we're coming into the 11 megahertz band. Nothing. It's real easy to go right past stuff with a radio like this. You just have to be very gentle on the tuning. Okay, we're heading up to past 11 to 13.5 megahertz. Okay, so that's another ham band we're running into. This is the 14 megahertz 20 meter ham band. Actually says amateur right under the pointer there. Lots of digital transmissions from ham guys these days. A lot less voice, I think. Okay, so we should be getting up into 15 megahertz. Somewhere around here. Getting harder and harder to tune this radio because the band is getting squished more and more. So that's probably Cuba. Getting up 17 megahertz, not likely. Not likely to hear anything more above it here. There's all kinds of stuff right in here. You can hear it all. So that station either disappeared or this thing just retuned itself ever so slightly. That's a heck of a hard radio to tune. Unfortunately, reception's not bad, sensitivity is very good, but selectivity, well, I guess the selectivity of the radio itself is pretty good, but your ability to select the station with the tuning thing is really, really limited. And that's the case with all these radios that have a huge band spread from, not band spread, but a huge band from 6 megahertz up to 20. That's gigantic. That's crazy. There we are. I think from here it's all about the cabinet and a couple of light bulbs and that. Fantastic. Okay, so that was a tough row to hoe, but I made it. Thanks a lot for watching, and see you on the next video.